Hey there, in this video we are going to go ahead and talk about how we can use a certain test taking skill, specifically plugging in answer choices to solve an either 2-variable or 3-variable system. So this is going to be a great time-saving method, especially for those 3-variable systems, because you won't necessarily have to go through and solve. If you are more confident with solving it by hand, if that's something that you're more confident with, then maybe you'll choose that method. But especially on a 3-variable system, this method is going to be very beneficial. So just a quick recall, if we have 2 or more equations with 2 or more variables, that's going to be a system of equations. And remember, when we look at solving a system of equations, that means that we are finding the set of variables, x comma y, that create the ordered pair that represent the point where those two lines cross. So that is a system of linear equations with 2 variables. So this concept, again, is what allows us to use this time-saving technique to solve multiple choice questions, because we're able to take the ordered pair answer choices and plug them into the system of equations and see, is that in fact the point that is part of both lines? So it has to be the one point that is part of both of these lines in a 2-variable 2-equation system. All right, and then we're also going to look at 3-variable 3 equation systems. And so with the 3-variable 3-equation ones, we are really technically looking at a 3-dimensional answer. So a 3-dimensional axis, if I were to graph this, so that is your x-axis, your y-axis, and your z-axis. So there's 3 dimensions. Think of this 3-dimensionally, and that is where your answer would be if I had 3 lines, let's say, graphed here, 3 planes technically, graphed here like this, and another one, and another one. So the one place where they all meet is going to be your answer in that case. All right, so that's what we'll be looking for again in the answer to a system of equations. So that time-saving technique, again, is just going to be to take each answer. So you're going to take each answer choice here, A, B, C, D, and we're going to plug it into each equation in the system of equations. So we'll start with answer choice A, 7, 5, and we'll plug it into the first equation. If it works for the first equation, then we'll try the second equation. If it works for both, then it is the answer. If it doesn't work for one, or it doesn't work for either, then it is not the solution to that system. So the way that I would approach it is I would go ahead and start with answer choice A, and I'm going to start with x equals 2y minus 3. I'm going to plug in x as 7, y as 5. So that's going to be x equals, let's backtrack. There we go. 7 equals 2 times 5 minus 3. So that's, again, your x is 7, your y is 5. So we plug those in, and then we just simplify the left and simplify the right. So no moving things around, no inverse operations, just 7 is on the left, and then 2 times 5 is 10, minus 3 on the right side. 10 minus 3 is 7. So we end up with 7 equals 7. So with this one, 7 equals 7 is a true statement, which means 7, 5 does work for the first equation. Now we need to see if it also works for the second equation. If it works for both, then we would circle A as our answer, and we would know that that's our solution, and we could not worry about plugging the rest in. So let's go ahead and also plug in our second equation. So 5x minus 4y equals 9. So we're going to do 5 times x, which is 5 times 7, minus 4 times y, so 4 times 5 equals 9. 5 times 7 is 35. And then negative 4 times 5 is negative 20, so minus 20 equals 9. 35 minus 20 is 15. 15 is not equal to 9, so that tells us A is not the correct answer. So then we go on to B. We do the same thing with this equation right here. So we're going to plug in our x is 2, our y is 3. So we'll say 2 equals 2 times y, so 2 times 3 minus 3. Simplify that right side because the left side is already just 2. 2 times 3 is 6, and then we have minus 3. So 2 equals 6 minus 3 is 3. That is not a true statement. So I don't even need to check this second equation for the ordered pair 2, 3, because if we know it does not work for the first equation, we know it's not going to matter if it works for the second one, because it will not be a system, a solution to the system unless it is a solution to both equations. So this B right here, we can go ahead and cross out. All right, so let's go ahead and take a look at C. So again, we're going to go ahead and plug into this equation with the x equals 2y minus 3. X is negative 11, y is negative 4. So that's going to be negative 11 equals 2 times negative 4 minus 3. Negative 11 equals 2 times negative 4 is negative 8, and then minus 3. Negative 8 minus 3 is negative 11. So we have negative 11 equals negative 11, which is a true statement. So this answer choice C does work for the first one. Now we need to try it for the second one. So for the second one, we're plugging into this 5x minus 4y equals 9. So we're going to do 5 times x, so 5 times negative 11, minus 4 times y, so 4 times negative 4, equals 9. 5 times negative 11 is negative 55. Negative 4 times negative 4 is positive 16. Negative 55 plus 16, when you add negative 55 plus 16, you get negative 39 equals 9. That is not a true statement, so that tells us that C is not a correct answer. So that should tell you that D is correct, but let's just go ahead and show that. So x is 5, y is 4. So that's going to be 5 equals 2 times 4 minus 3. 2 times 4 is 8. Subtract 3, and you get 5. So we do get 5 equals 5 in the end, which is a true statement. So 5, 4 does work for the first equation. Now we need to check it for the second equation. So that's going to be 5 times x, so 5 times 5, minus 4 times 4 equals 9. 5 times 5 is 25, minus 16 equals 9. 25 minus 16 is 9. So we get 9 equals 9, which also works. So we can see that D is our correct answer on this one because it does, in fact, give us a true statement at the end of each of these when we plug it into each equation. So it is an ordered pair that satisfies both equations in the system, and therefore it is the solution to the system. So now we're going to look at a 3-variable, 3-equation system. With the one that we just did, you really could go either way with whether plugging in answer choices or actually solving is simpler. It really just depends how confident you are with the method to solve the system of equations on that last one. This one, typically it's going to be faster to plug in the ordered triple. So these are called ordered triples. The first number is x, second number is y, the third number is going to be your z. So starting with the same plan from the last example, we're going to plug in 10 to 9 into each equation. If it works, we'll start with the first one. If it works for the first one, then we'll plug it into the second. If it also works for the second, then we'll plug it into the third. If it works for the third, meaning all 3 it works for, then that would be the answer. So 2x minus 3y minus z equals 5. So we'll have 2 times 10 minus 3 times 2 minus 9 equals 5. 2 times 10 is 20. Minus 6 minus 9 equals 5. 20 minus 6 is 14. Minus 9 equals 5. 14 minus 9 is 5, and 5 does equal 5. So that does work out for the first equation. So now we're going to go ahead and plug that same ordered triple into the second equation. So x minus 2y plus 3z equals 22. So we'll start with x, which is 10, minus 2 times 2 plus 3 times z, which is 3 times 9, equals 22. So we've got 10, negative 2 times 2 is negative 4, 3 times 9 is 27, and then equals 22. So we have 10 minus 4 first, which is 6, plus 27. 6 plus 27 is 32, which does not equal 22. So A is not a correct answer on this one. So now we're going to plug in that second order triple x, y, z, our 11, 4, and 7 into this first equation. So 2 times 11 minus 3 times 4 minus 7 equals 5. 2 times 11 is 22, minus 3 times 4 is 12, minus 7 equals 5. 22 minus 12 is 10, so we get 10 minus 7 equals 5. 10 minus 7, though, is 3, which is not equal to 5. So that tells us B is not a correct answer. So then we go ahead and try C, which is -1, -4, and 5 for x, y, and z. So that's going to be 2 times -1 minus 3 times -4 minus z, which is 5, equals 5. 2 times -1 is -2. -3 times -4 is positive 12. And then we have minus 5 equals 5. -2 plus 12 is 10. Minus 5 equals 5. 10 minus 5 is 5, which does come out to equal 5. So we know that equation 1 works for option C. Let's go ahead and try equation 2. So that's coming to this x minus 2y plus 3z equals 22. So x is -1 minus 2 times y, which is -4, plus 3 times z, which is 5, equals 22. So we have -1, and then -2 times -4 is positive 8. 3 times 5 is 15, equals 22. -1 plus 8 is 7, plus 15 equals 22. 7 plus 15 is 22, so 22 equals 22 tells us that it also works for the second equation. Now we can't just assume it works for the third. We do have to actually go ahead and try that. The third equation we have not plugged into yet, so I'm going to rewrite that. 3x plus y minus 5z equals -32. So that's going to be 3 times -1 plus -4 minus 5 times 5 equals -32. 3 times -1 is -3. -4 is next. You can write plus -4 or just -4. Either way works. -5 times 5 is -25, and then equals -32. -3 minus 4 is -7, and then we still have -25, equals -32. -7 minus 25 is -32, which equals -32. So that also works out. So that tells us that C is the correct answer choice because it works for all three equations, which means technically you do not have to try D. If you wanted to, you could, and you would find that it does not work for all three of them. So just a quick review, when we are given a system of equations, that's either going to be 2 equations with 2 variables, or it'll be 3 equations with 3 variables. And if it is multiple choice, so if those two things are given to us, a system and it's multiple choice, then we're going to plug in each choice, meaning each ordered pair or ordered triple, into each equation in the system. If we are left with a false statement, so that means if we are left with something like 4 equals 7, then that means it is not the solution and we would eliminate that choice. But if it does work for, let's say, the first equation, then we go on and try that same ordered triple or ordered pair for the second equation. If it's a 2 equation system, then if it works for both, then that's your answer. If there's 3 equations, then you go on and you check for the third one as well to confirm, yes, it works for all 3 of those. And then that is your final answer.